All right, let's go. Stream is live. And let's start software. Get everything ready. And it's loading. Okay. Let's start. Like so. Here we go. Twitch on Twitch. And here we are. We just close some chats and mails. Okay. Here we go. This is where we left off yesterday. I'm trying a new filter on filtering out the background because I'm in the office. Not to give away any colleagues, so it might flicker a bit, but let's try it out. So, where did we leave yesterday's model? I'm not going to do a super long stream today because it's late, and even though taxi services are fun, yeah. So let's see what we have. We have the taxis. We had someone yesterday asking like, yeah, but what about statistics? So we ended up doing statistics, recording them in a table format. Boom. Now the simulation's been running for 11 days. It's going to taxi, simulation stats, and we have, for a lot of the hours, nothing is happening. So this is what the taxi cars have been doing hour by hour. But let's also investigate how good are we as a taxi service in fulfilling our customer needs. So if you remember, we have the taxi jobs, and each row in this data set, we only have 8 rows, each row represents a customer calling the taxi service saying, hey, I want to pick up. I want to go from, let's say, side town, and I want to head downtown. This is the city map right now. We have side town, out of town, and downtown. So, when the customer makes the call, we have the time he places the call, but we also have when he wishes to be picked up. Now we're curious, of course, when is the customer actually picked up, and when is he delivered to destination? So for each job, let's record the actual pickup time and the actual drop off at the destination time. So then we can start measuring how well this taxi system performs. So the taxi jobs, and then you get requests with different IDs. We get the data into the taxi service system. When pickup. So let's do recordings of the timestamps when actually pick up. So when we actually pick up. And when actually drop off. And then we can start measuring how good we are. So on the pickup sensor, we're doing the pickups. So we have if the taxi is empty, we assume we're doing a pickup, and the customer is here. You move the customer into the taxi, and then you wait. So let's imagine before we start the wait here, we record the time. Record timestamp of when we picked the customer up, like so. So the customer, as I remember it, has an ID. But let's stop the code here. Now I'll put in a comment of what I want to do. And when we arrive here, there should be a customer._ID. No, there is not. Customer has an _ID. Why isn't that working? Because the customer hasn't been assigned to variable. So customer ID is 3. I needed to go past this row. Customer.id is 3, which we know corresponds also to the row in this table. But that could be a bit dodgy. So we're actually going to improve the requests table and put the ID as the row index and have this be a string instead. So string, so we give it an ID. So we can actually use the customer ID to find the ID, to find the correct row here. So when we pick someone up, we want to go into this table, which is located in taxi control. So root.taxicontrol.requests, and when actually pickup, for which row? The customer ID row is equal to right now. So root event controller abs sim time. That is when we actually pick up this customer. So if we put a breakpoint down here, remove this breakpoint, and run the model, the ID, we're trying to write ID as a new row, but remember we changed it to be a string, and now we're giving it an integer. So if we want to use the row, we could also randomize this unique ID in some way, but I'm just going to use the number for now. So that's going to be a number to string. So we convert the number to a string. And then it's working. And here, customer ID, so the customer here still has ID as an integer. So that needs to match, it has to match the string. Like so. And so are we, I'm just bringing up the Twitch stream so I can see for myself. If someone is writing in the chat, it would be nice to see that. So I can respond. I'm just logging in. And then we're going to do the string conversion. All right. Logging into Twitch is very hard. So it takes a bit of time. Need to provide the correct code for. That was the wrong code. That was the correct code. All right. No chat messages yet. Okay, let's replay this. What was the issue? The customer ID should be a string, and now it is. And now we have when actually pick up customer number 3 is that time 53 seconds after they wish to be picked up. So I'm gonna measure all the customer pickups, and then we're gonna see if some of them are late. They're all gonna be late. Let's play the simulation for always 6 hours. And now they were actually always picked up these times. And then also let's record the actual drop-off. Assign the request pickup. So when do you drop someone off? Is that up on the pickup sensor? Yeah, so the taxi is stopped. And then I think we wait 60 seconds until we record when we drop the customer. So when actually pick up is going to be when actually drop off of the customer that we need to reference before. The customer's ID is going to be that time. So now we're recording when we're dropping them. In this case, we can see we actually drop them off here. And now we're going to do some additions to this. So how long were they in the taxi? So let's record that as a time spent inside the taxi. Call it for customer delivery. What do you call it? How long is the customer inside the taxi? Yeah, time in taxi. Let's be very explicit. So I'm going to say customer time in taxi. And then we're also interested in how late were we for the pickup. Customer, yeah, late for pickup. So let's add these two. So when we drop someone off, we know that the time in the taxi for that customer. Hey, hello, Malun TM. I am continuing the taxi modeling. I don't know if you saw something of this before, yesterday or the day before. Right now, I don't know if the code is going to crash at this point. We have taxis, doing pickup jobs, delivering some customers. And we are recording the data here. You can see the data filling in live. Speed it up. Some new jobs coming in. And we're recording some statistics on each customer order. So one line could be viewed as a customer order. So for a taxi service or for a production, if you have a factory, it's also an order, you could say, that a customer wishes to have fulfilled and they want to be picked up at this time. But when they actually were picked up is this time. So how late were they picked up? Late for pickup. So let's take the difference between when they had a wish to be picked up. This is their wish for pickup time. Minus now. So if this is bigger, and this is smaller, this difference would be negative. So maybe turn it around. Like so. Call it delay. And if delay is greater than 0, that means that we have a delay. So if we have a delay, we're going to write that we were late for pickup. Oops, no. Let's write that here. So late for pickup. We want to write to late for pickup. Messed something up. So late for pickup is how late we were. So write in the delay. And the customer time in taxi, we can calculate when we drop them off. The customer time inside the taxi is the difference between when you actually pick them up and when you actually drop them off. So it's this when you actually drop them off minus the time when you pick them up. When you actually pick them up. Minus actually pick up. Like so. And let's see if we get these two columns filled in correctly. Let's run. Go. Doosh. The customer time in taxi, 3 minutes. So it was picked up at 31:04 and it was dropped off at 34:05. So that is roughly 3 minutes. Yeah, 3 minutes here. And we were late for pickup in all cases. Late for pickup. So what are we going to do about the taxi service to make them never being late for pickup? One very simple thing we could do is look at which taxi is the most late. And then we always send out the taxi that much in advance. But that means we cannot know this, but we can know how much earlier we need to start if we have studied the system beforehand. So let's see if I can generate some more jobs. And this is going to be, I don't know, I'm just going to take it and double it. Double the jobs, take the same times, see what happens. Should work, right? Unknown index in the taxi fleet. Okay, we're starting more current jobs than we have available taxis, and the model is not really adapted to that yet. So I'm not gonna use that approach. Or we can just take that this is instead at 0801, 08 51, and this guy wishes to be picked up at that time, and this pickup is, he's calling when he wants to be picked up, basically. He wants to be picked up 1 minute after. And let's do the same here, but this is at like 5 minutes later. And he wishes to be picked up 1 minute later. No, it should be a 6. Something like that. And take these 2 rows, duplicate them here and here, but increase the pickup time to be 07. 06 is fine. Yeah, and if we init, does it sort this table? Yeah, it sorts the table, so that's good. Welcome to the stream. We're still having too many busy taxis. Let's cut away 3 rows. What I basically wanted to achieve by this, and now the logic cannot handle to have that many requests. Let's see if I can trim it down then. 10. Okay, I get the same issue. What if we go back to the initial first 8? What's so magic about that? Looks like something changed here. Oh yeah, it changed the order. I basically destroyed the order data that I had. So you're gonna get 8 jobs at the same time, and I only think we have that many taxis. So it looks like we should. Can I get the data back? Let's just, because I didn't want to change the data really. I want to keep working on the same data so we can get the consistent results here. Let's save this as a new model. Call it taxis. And open the old one. Just see if we can steal back the old data. Here we have the taxi jobs. 1, 2, 3, 4 columns. Let's copy it back into taxis. 1, 2, 3, 4. Yes, we have the data. Can we run? Yes, we can. Nice. So the maximum time out of this is around 2 minutes. So let's schedule all taxis to leave 3 minutes before they should pick someone up, so we can make sure that they're on time. That would be when the taxi is signing the request to a taxi. And then that happens immediately, so it's the time in which we schedule this method. Is that done in add request? Yeah, so here is when we want to pick up. But let's introduce a pickup. Oh, I'm going to zoom in. So we're telling the taxi to go do a pickup. But when pickup is exactly when it leaves. So when to leave is going to be a date time. And that is what we want to paste in here. When the car should leave the garage. When to leave should then be when the customer wishes to be picked up minus biggest delay. And the biggest delay we've found by looking at the system, looking at the data, is around 2 minutes, so let's use 3 minutes. 3 by 60. So the biggest delay, so you should leave at that time when the customer wishes to be picked up minus the biggest delay. We just put that in, run the model, and see. And we get no late pickups. So they wish to be picked up at these times, and they were actually picked up always slightly before. So that's great. So I think this concludes today's stream. I'm going to make it a short one. What we did today was simply start adding measurements on each customer order that we performed, studying how late did we deliver compared to when the customer wanted it delivered or being picked up, and then adjusting the model, adding some logic to compensate for that delay. So this means that if we were simulating a factory, a production system, that we have actually done a little study to know how much beforehand you need to give out maybe a production order if you want to meet the customer demand just in time or in good time. So thank you for listening in today, and I think next time I'm streaming I'm gonna do not a big system like this. I'm gonna do a small machinery instead, so production equipment with some nice cogs moving around producing stuff. So see you next time.